Okay, let's continue. Take a look at the function and their graph. We are going to just see some of the basic characters of some functions graph. Last time we talked about increasing, decreasing, and constant function. Let's take a continue look at the functions and the maximum and minimum. Okay, so those called variety, maximum, and relative minimum. So relative is because we are comparing with something. Okay, for instance, I'm just running a graph of functions. A functions graph has to pass the vertical line test. Just keep thinking about that. Alright, so that is my function. Let's take a look at some of the points. If you see this point, it might not be the highest point along the graph, but if I only consider this interval, that's the highest point, right? So this point can be displayed as an ordered pair A, f of A. So we call this as relative maximum because it depends on what interval you are talking about. So this is relative maximum. So the relative maximum is only considered within an open interval, not closed interval, which means we don't compare with the endpoint. Again, take a look at this one. This one also is relative maximum. On the other hand, if we take a look at this point, it seems like if I can define an interval, and this point is the lowest point, so we call this one is relative minimum. So that's this point. And another character of the functions graph is we talk about symmetry. So symmetry is related to even and odd. So we call those even or odd functions. Let's take a look at the definition of what is even functions. We say the function f is an even function if, when you evaluate, f of negative x is the sum of f of x for all x in the domain of f. Okay, later on I will apply more math symbol in here. For every, we will say for every x in the domain of f is an element of the domain of f. So these are the mathematical symbol I will apply in this course. So what does that mean is, let's take a look at the graph. Okay. Some of you might have already known what a quadratic functions graph looks like, which is a parabola. Indeed, parabola is a graph symmetric about y-axis. Right? And also, quadratic function is an even function. The reason is, for instance, this maybe it's negative x, and the same distance from the other side is x. Then the corresponding output for here, the f of x is the same as f of negative x. Therefore, quadratic function is an even function. So the even function, we say that the function graph is symmetric with respect to the y-axis. Similarly, if we take a look at odd functions, So the definition of that is the function f is an odd function if f of negative x is equal to negative f of x for every x belongs to the domain of function f. Alright, so what is odd function? Very simple example is the linear function. We learn the identity functions y equal to f of x or y equal to x. Okay. So this is an odd function. The reason is an odd function, for instance, if I have x equal to 1, corresponding value is 1. And then if we take the opposite of 1 with a negative 1, the corresponding output is the negative 1, which is opposite as 1. Okay, so you can see another one which is very common seen odd function is the cubic function at y equal to x to the third power. More or less, it's approximately 1. So you can see that maybe this is 2. 2 to the third power is 8, and they can examine that when x equals negative 2, the corresponding output is negative 8. So there's an opposite here. So the graph of the odd function is symmetric, also symmetric, but it's symmetric with respect to this point is called origin. Okay, so we say that the graph is symmetric with respect to the origin. Okay, so those are about is the odd or even function. Let's take a look of an example. We are going to determine whether the function that we call the g of x is equal to 3x cubed minus 5x7 is even or odd or neither. Okay. In order to do this problem, we need to know what kind of theorem or definition we can apply to determine this. So recall the definition. We say that if a function is even, then if I replace the input is from x to negative x, the output should be the same of f of x. And if it is odd, then when I replace the input by negative x, the output is the same as negative f of x. Okay. For our, no matter this way or that way, they both need to examine when you replace the input by negative x, what happened to the output. So for our problems in here, I'm going to evaluate g of negative x, which means in this case, your input is negative x. So replace the input by the function definition. G function defined as 3 times input to the third power minus 5 times input to the 7th power. So that is 3 times negative x to the third power minus 5 times negative x to the 7th power. So that is equal to negative to third power. So you have negative times negative, still get negative. So that's negative 3 x to the third power minus 5 negative x to 7 power, so it's up power, the result still negative, so the same as negative x 7 power. Distribute the negative inside, so we have negative 3 x cubed plus 5x7. Let's compare. G of x is given as 3x cubed minus 5x7. And you can see that obviously this one is not the same as this. So with that, we can conclude this function is not even. But let's take a look. How about odd? Is that the odd function or not? Okay, negative g of x is equal to negative 3x cubed minus 5x7. Distribute the negative inside, we will result negative 3x cubed plus 5x7. Alright, well, it seems like they are exactly the same, so that's the same as negative g of x. By the definition, we can conclude that it is arc function. So therefore, g is an arc function. Let's take a look at another example. I'm just going to change one of the exponents. Okay. We are going to determine whether h of x equals to 3x cubed minus 5x6 is even or odd or neither. So similar idea, we need to check h of negative x. Okay, h of negative x. Replace the input by negative x. So with that, the odd degree, we still got negative. With the even degree, that is got positive. Well, positive in this part, still apply the negative in front of that. So we're still comparing with the original one. H of x is equal to 3x cubed minus 5x6. Let's take a look. Well, they are not the same, isn't it? Because the coefficient of x to the third power is different, so it's not equal. So from there, I can conclude that it's not even. How about negative h of x? So that will give me negative 3x cubed minus 5x6. Distribute negative inside. Negative 3x cubed plus 5x6. Let's compare that. Still not the same because the x to the 6th power coefficient is not the same. So they are not, let me write in here. So not the same. So with that, I can conclude it's not odd. So this is not even or odd. Therefore, we say that excuse me, because the function is lowercase, h of x is neither odd or even. Why do we want to talk about even and odd functions? The right way you can see is when we graph the functions, then we can apply the symmetry. For instance, this problem, and this function is odd function, then we know that the function will be symmetric about the origin. When you graph that, you have that in your mind. And this one is neither, so there's no symmetry at all. I cannot say it at all. It's not symmetry about y-axis or origins, so we cannot take advantage of that feature. Alright, so that is the even of odd functions. The next thing in this section, which is the last thing we are going to cover, is about the piecewise functions. Piecewise function, by looking at the name, right, you can see it's by pieces, right? So your function graph will be formed by pieces. I only can give you some example from here. That's not such a formal definition for the piecewise functions. Let's take a look at the first functions. F of x is equal to half of x squared if x is greater than 1. 2x minus 1 if x is less than 1. And you can see this function is divided by two pieces. One piece right here, one piece right here. How can I know which piece I'm going to use? Depend on this condition. If your input is greater than 1, then I'm going to use the first piece to evaluate. If my input is less than or equal to 1, then I'm going to use the second piece to evaluate. We are going to find several of the values. F of 0, f of 1, f of 2, f of negative 2. Okay, so take a look at this. F of 0, since 0 is less than 1, then we are going to use the second piece to evaluate that. So the second one defined as 2 times input minus 1. Therefore, it's negative 1. How about F1? 1 is not greater than 1, but 1 is less than or equal to 1. So I still use the second piece to evaluate. 2 times input minus 1. So that gives me 1. F of 2. 2 is greater than 1. Therefore, I'm going to use the first piece to evaluate. Half of input squared. Half times 4. That's equal to 2. F of negative 2. That's half. Oops, excuse me. Why do I use half? Maybe it's wrong. Let's check. Don't forget to check the condition. Is negative 2 greater than 1? No. Then we cannot use the first piece. Is a negative 2 less than or equal to 1? Yes. Then we use the second piece. So it's not half of x squared. It's 2 times x minus 1. That's negative 5. Let's take a look at another one. I'm going to define a function g of x is equals to 0 if x less than negative 4. Negative x if x is between negative 4 and 0 but not including 0 equals to x squared minus 1 if x is greater than or equals to 0. We are going to find, that's g of 2, g of 1, g of 0, g of negative 1, g of negative 4, g of negative 10. How about that? Alright, so let's take a look. G of 2 is, let's see which condition satisfied. The last one, greater than 0. So that is 2 squared minus 1, that will give us 3. G of 1 is greater than 0, still use the last piece to evaluate. So that's equal to 0. How about G of negative 1? Negative 1, well, is the second piece, isn't it? Because negative 1 is greater than or equal to negative 4, less than 0. So that will be negative of the input. So that give me 1. How about G of negative 4? Negative 4 is equal to negative 4, so it's still second piece. So negative of my input, so that gives us 4. G of negative 10. Negative 10 is less than negative 4. So that's negative 10. So that's equal to, oh, gosh, I made a mistake. Sorry for this. So, see, a lot of time we make careless mistakes, so it's always useful to double check what you're doing. Ask yourself the reason you're doing that. Again, G of negative 10. Negative 10, I said that it's less than negative 4, right? If it's less than negative 4, then we should use the first piece, which is no matter what your input is, the output should be equal to 0. So that is equal to this big 0. Alright, so that is the end of section 1.3. So I look forward to share my knowledge with you in the section 1.4 next time. See ya.